There are a number of different techniques we could use to make the wheels auto-rotate. For the purposes of this demo, I'm going to go ahead and just use a basic expression, and that should do really well for what we need. I do have a few variables that I need to find out for that expression to work. So let me just bring up a notepad, and I'll go through the expression actually. So the expression that I'm going to be using is percentage times by the distance times by pi over pi times the radius. Okay, so what the heck is all that then? So let's work through it. So we've got a number of variables here. Pi, if you don't already know, is equal to 3.141, and Max already has this built in, so we don't really need to, dig deep on this one. We just have to know that we need to use pi for this expression to work. The next one is the distance. So this is the actual distance of the path that we have. So the path that we've created, we need to find out the distance of that, how long it is. The next one is percentage, and that's the percentage amount that the car is along that path. So it could be 25% of the way along the path. Obviously 100% is the full way. So we need to find that out, and we also need the radius of the wheels. So all of these are pretty simple to find out actually. So let's take the distance for instance. Let's have a look at that. So I'm just going to minimize this, and if we look at the path, and if we just grab hold of it, come across to the utilities tab, and this thing here, the measure tool, just grab it. If you just click it, and let's scroll down, it's going to give me the length already. So that's it. That's how I find this out. So let's just record that in our notes. So back to the notepad. I'm just going to go, the distance equals 32518.031. So the percentage amount along, right now it's at 0%. The car is not actually along as well. If you have it at the 0 frame, the car hasn't moved along at all. So to find that out, we can put a direct input on that. So let's just leave that one for the moment. That can be done as we work through the expression. And the radius of the wheels, okay, that's pretty simple to find out as well. So let's just zoom in a little bit on one of these wheels. Look at the front one. And the diameter of a wheel is from the bottom to the top, how long that is. We need the radius, and that's going to be from the bottom to the center of it. And luckily we went across before when we first started rigging this car up, we centered out all of the pivot points on the wheels. So that's really simple for us to get to now. So let's go to the create panel, come across to helpers, make sure you're on standard, and we've got something called a tape. And to create that, just grab it and click and drag in your viewport, and you'll notice we've got something that looks like a point helper at the end in this pyramid, and this gives us calculations and readings out. So I'm just going to right click and end this tool. I'm going to grab this point helper looking thing, hit Shift and A for a quick align, and I'm going to align that to the tire, which should pop it right into the center. And I'm going to grab the pyramid, I'm going to hit Shift and A again for the quick align, and I'm going to align that down to this bottom control. And with that selected, if we move across to the modify panel, I can actually find the length, and that's going to give me, that's the actual radius that we need. So let's record that in our notes again. So the radius equals 28.943. Alright, let's just minimize that down, and I can delete that out now because I don't need it. Alright, so that's all of the information we need, all of the variable information that we need for this expression to work, so we can get on and actually put this expression onto one of the point helpers that we've got. So if I just zoom in again on the wheel, hit F3, you'll notice that we hit out the point helpers before, so we're going to need them back. If I just right click and unhide all, and this smaller guy, he's the guy, I think, if I remember correctly, if I go back to my motion panel, he should have rotation. So he's got the orientation constraint for the steering. This guy controls the steering. So it's this guy that controls the actual rotation of the wheel itself. So let's take a quick look at this. If I go back up here to my coordinate system, turn this to local, and it'll just increase the size of that so you guys can see it. It looks like at the x-axis that we're gonna want to rotate. But remember, like before, I don't really like local. I prefer gimbal or parent. So let's just jump back to gimbal, and you'll notice I'm missing one of my axes running around here. and that's because this thing's got gimbal lock already, which really sucks. But luckily there's no inputs or outputs on this thing just yet. It's just parented in a hierarchy, so we can get rid of this really quickly. Just hold on Alt, right click, freeze transform. When this pops up, I'm just going to hit yes, and you'll notice that I got my extra manipulator back, and X is actually the axis I want to affect, so that's really cool. So with that done, let's go and assign a controller. We're going to want a float script on this, so open this out, rotation 0, Euler XYZ, and I want the X because this is the one we're going to want to rotate, and let's just click assign controller. And I want a float expression, so let's just click that, hit OK, and we get this awesome dialog box. If you've never done expressions before, I suggest taking a bit of time just to learn about this. Maybe press F1, go to the help files, and learn about what you can actually do here. So with this done, let's bring back my notes. So I need pi, distance, percent, and radius, and I need those all as scalar values. So the first one is actually pi we don't need to create because, like I said, Max already knows what that is, so we don't need to put that in. So we just need distance, percent, and radius. So let's create those right now. So we've got distance, just create that. We've got percent, let's create that one, and radius. And all of these need those values, so let's bring those back. So distance is it's not gonna change, so I'm just gonna copy that. And let's minimize that back down. So the distance is a constant value, so I'm going to assign a constant, and I'm just going to paste that in, paste, and that's okay. So you can see now distance is equal to 32518 and whatever the decimal point was after that, I can't remember. The percentage, like I said, we're going to assign something directly to this, so let's assign a controller. And we're going to have to dig for this one a little bit. So we've got our line. And actually, I think that's not what we need. We need, if I just scroll up, we need this guy. So this first point we actually need. So let's go in here and have a look. And we've got let's just digging down. We've got the path constraint that I'm looking for in here. So let's just zoom down a bit. And we've got the percent in here. So all I've done is I've grabbed this first point, I'm digging a little bit through the transform, down to the position, down to the path, and I'm finding that percent, and I'm just going to give it that value. So I'm going to go OK. So as you can see now, it's got a controller assigned to it. It's 0.009 position controller path constraint controller, and it's the percentage of it. So that knows what percent along that's actually going to be now, which is really cool. And the radius, we need to assign another constant. Let's just bring that back again. So the radius is 28.943. I'm just going to copy that out. And I'm going to assign a constant. Paste that in. Okay. That should be cool. So we haven't changed anything in the expression box just yet, so we need to grab that expression. Luckily it's already written out for us, so I'm just going to copy it. I'm going to paste it. And I'm going to evaluate, see if anything comes up wrong. Nothing did. So let's just move this off the screen for just a second. And let's move back to our car. We should still be able to rotate this, as we can. And as this scrubs through the timeline, we should see the wheel rotate. Now unfortunately I've only got 100 frames, so this is really quick. And I need to slow this down a lot. So I'm just going to grab my time configuration button down at the bottom here. And I'm going to set my end time to 2000. With that okayed, let's grab these guys. And I'm just going to make that a bit smaller again. I'm going to grab these two. I'm just going to slide this all the way out to 2000, so we should be able to scrub a little bit easier and see what's going on. And let's check this wheel rotation. So just move to the side. And as I scrub through, it still looks pretty quick. So we probably need to increase that even more just so that we can see it. So let me go back to my time configuration. Let's go to 10,000. This is a very long animation now. Should be fine. Let's just scrub that out. And let's move in. Still really, really quick. But you should hopefully be able to see that wheel rotate around. I don't know if we're going to be able to see it as we... There you go. So we can see that wheel rotating as it moves past the screen. It's a little bit jerky, but you get the idea. So that wheel rotates automatically, and remember, we've already got the control on top where we can rotate over the top should we need to maybe spin those wheels up or whatever. So that's rotating around really fine. Awesome. So we know that that expression works. We know we've got all of the variables that we need, and we can go ahead and apply that to the rest of the wheels. So if you just go ahead and do that, look through this video again if you get a bit stuck, but it's definitely good practice to work out how these expressions really work.